little study guide that you could go through to make sure you know what you need. If you are in Chemistry 30, please check out my website. The link is in the bio, has all the units, and as you look through there, worksheets, practice quizzes, and practice tests, and more review. Sorry, I'm just trying to roll this up, but it doesn't want to. There we go. That's too far. Okay, so when we're starting for things you have to know, when you started the organic unit, probably on the very first day, you were told what's organic and what's inorganic. What you really want to pay attention to is what's inorganic, right? We know if you're organic, you have carbon, you have hydrogen, but there are some exceptions. So a few of them are you cannot be bonded to metal and you can't be a carboxide. You also cannot be an oxide. So those are a few that we can take out right away. You also cannot have the CN ion. And once again, you can't be bonded to a metal. So if you know what you're not going to be, then the ones that are organic would be what's left. So 1, 3, 4, and 7. Then we move on to being able to describe significant organic compounds in daily life. So I just added this part here. This has been definitely coming up more and more on the diplomas. It's been on the very last one from June, and it was on the one before that. So you want to be able to look at things like propane and say that propane is used in a barbecue, or butane is used in a lighter, or things like methanol or ethanol. The nice thing about that is that the questions I've seen so far is they might list 4 different organic compounds and then ask about 2 of them. So you would only need to know a few from the list. So when you're going through and studying, definitely look at the theory. Make sure you are reading what certain compounds are used for. Don't skip that over. You do see photosynthesis come up and cellular respiration come up again. So you've probably already seen this in your chemistry classes, but it's coming up one more time. So here is an example. Here it's asking the reactants of photosynthesis. So we have sunlight. It also takes in carbon dioxide, and it will take in water. And then we have our products of oxygen and glucose. If you are looking at complete hydrocarbon combustion for the products, we know that it will produce carbon dioxide, so number 3 again, and water. It is telling you you're in an open system. So if it's an open system, water will escape as a gas. If it is a closed system, then water is going to be a liquid. The next part is knowing the naming of all of your groups and basic theory. So just going back for when we're talking about basic theory, so that might touch on the different types of compounds you can find, like propane, and telling you what it's used for. Say you're looking at something like an alkane. Basic theory could be that you are a gas when you're smaller, and as those alkanes get bigger, you are going to be a waxy solid. Talking about if they're polar, non-polar, things like that. So it's usually, when I've taught it, I just give a theory page and you go through it, but you are spending a lot more time being able to name and draw. You do want to know the difference between the term saturated and unsaturated. So we know carbon can bond to 4 other atoms. If you are saturated, it means that carbon is bonded to as many atoms as it possibly can, which is 4. So you have all single bonds, so you would be an alkane. If you are unsaturated, you are now showing a double or triple bond, and now you're not bonded to as many atoms as possible because you had to share some extra electrons. So to be unsaturated, you are an alkene or an alkyne. Now, the other part is, and this comes up a little bit later, is knowing your bromine test. So if you do add liquid bromine to a solution that contains an alkane, you're going to have a substitution reaction, but that brown color will stay because bromine as a liquid is very, very dark brown, kind of orangey sometimes. If you have a alkene, it's going to be added where the double bond breaks and your solution will become clear because that double bond essentially, or that compound, will just absorb that bromine. So do know your bromine test, knowing that when it stays brown or when it turns clear. Know the difference between aromatic and alphalic. So if you're aromatic, you must have a benzene ring. If you don't have a benzene ring, you're just aliphatic. So you can be cyclic and not aromatic. To be aromatic, you must have benzene. No isomers. So for instance, if you have any compound, right, with a certain amount of carbons, a certain amount of hydrogens, and maybe whatever else is there. If you're an isomer, you have the exact same empirical formula, but you're arranged differently. Know your series. If you're a homologous series, it would be like everything in the same group. So like methane, and then going up one, ethane, then going up again, propane, right? As long as you keep adding one carbon, you are getting bigger. You're part of the series. If you wanted to, you could start at ethene, and then you would have propene, and then keep going. And you can also do the same thing with your alkynes. You want to know your functional groups and your properties. We'll touch again on this in a moment. And your 5 organic reactions. So addition, breaking a double bond, elimination, forming a double bond, substitution, esterification, and combustion. So we want to know all of those reactions. So here are just a few old diploma questions, kind of going through some of this. I'm also just talking about the naming, so not quite yet. So just, you should know what all of these are. So alkanes, being able to identify it. Alkenes, alkynes, being cyclic, how to name it. Benzene, knowing that that will be aromatic. If you are on a chain that has more than 6 carbons, you are now the branch of benzene, and you are a phenyl group, just like if you were a methyl or an ethyl group. You want to know your halogenated hydrocarbons, your alcohols, your carboxylic acids, your esters, what it means to be branched, like your methyl, ethyl, propyl groups, so on. When you're nonpolar versus when you're polar, and when, again, those functional groups that we'll take a look at in a moment. So here's an example, benzoic acid. It contains, so if it ends in oic acid, you know you have a carboxyl group. And if it's benzoic acid, that means you have benzene, so it would be aromatic. This next one, taking a look, you have 2-methylpropane, 2-chloral, 2-methylpropane, and it contains A on the second carbon in the parent chain, and both have blank carbons in the parent chain. So if we're looking at what's on the second carbon, it definitely has branches, right? Because we have that methyl on both, and so that would be your branch. And then your parent chain would be prop, and prop has 3 carbons. So this is just theory, knowing what we can add in. Here there's some information. It also looks like it's going to touch on the bromine test, but it actually doesn't. In this question, you have cycloheptane, and we want to know what type of hydrocarbon it is. It ends in ane, meaning all single bonds, so it has to be saturated. And if it ends in ene, it is unsaturated. So your answer is B. So again, you've probably seen questions like that. They're very common. You'll see them again. Going through your functional groups. So if you have functional groups, you're adding something else to that parent chain. So like a halogenated hydrocarbon, our main ones, an alcohol, so that OH group, carboxylic acids, giving them now more of a polar. Actually, alcohols make it polar too. And then the esters, so being able to identify all of these. And then just noting one more thing here, because carboxylic acid does contain that acidic hydrogen, this is the only one that will affect your pH. So going to take a look, once you have all that information and you go through all of those groups, you should be able to take a look and be able to identify. So for instance, if something is aromatic, again, benzene ring, you could put number 1 or 2 here because they both have benzene. Carboxylic acid, you're looking for that C double bonded to O, but then a single bonded to H. So that would be here. I don't know why that was so hard for me. Unsaturated and aliphatic. Unsaturated, you're looking for a double or triple bond. So here's double. And aliphatic means no benzene ring. So this is just 4. And then halogenated hydrocarbon, you're looking for one of your halogens. So number 2. So sometimes the diploma will let you have more than one answer. So for instance, if you wrote here 2, 3, 4, 2, it still would have been correct. Physical properties. You do want to know these. Again, you probably went through these for each of them in terms of your main organic compounds, but going through boiling point, knowing that longer chains need more energy to break the bond, so your boiling point is going to be higher. Polarity, knowing that if you're adding on an alcohol or that carboxylic acid, you are now polar. Halogens will also make your molecule more polar. Solubility, don't forget that phrase, like dissolves like. So if you're a polar molecule, it will dissolve in a polar solution. And then opposite, if you're nonpolar, it will dissolve in nonpolar. And then the last one, the longer the chain, the less polar it becomes. So for instance, if you had like methanol is what I should have said. Methanol, this OH group is pretty significant. But if you had, say, a very, very, very long chain, then this OH group gets less significant. And so that 4 is why you're less polar. Going down here, you have a chart being able to bring in your own reasoning and figuring it out. So you have different alcohols. These are all, I believe, isomers of each other. Just for the first one, your OH group are on different carbons. And then the last one, you have a branch as well. So noticing here, if it's on carbon 1, you have a higher boiling point. When it moved in, the boiling point goes a little bit lower. And when you have another branch, it's even lower. So going over here, using only your information from the table, when the alcohols in the table are compared, they have the same. So they would have the same molecular formula because they would all be like the same amount of carbons, the same amount of hydrogens, and the same oxygen. If it was structural, it would mean that they were all arranged exactly the same. But they have different physical properties because boiling point is a physical property. To be chemical, you're changing your substance. Just adding on a few more things, know your polymer reactions. So knowing that you either are forming from a series of addition reactions or from a condensation reaction. Know the difference between an ester link and an amide link. Ester, I believe, is more focused on in chem, but you do have amides as well, and that's just when you have that nitrogen involved. Know what a condensation reaction is. So if you are forming water, you are a condensation reaction. So polymerizations can form water, right? If you are forming an ester or an amide link, and esterification also forms water, so that would fall under there. And then lastly, being able to separate crude oil. There are a few ways that you'll talk about. Fractional distillation is definitely the most popular. I think it's made its way on every diploma I can think of. But knowing cracking, that is probably in your textbook. Read that over as well, just in case. But fractional distillation is definitely more popular. That's pretty much organic in a nutshell. If your test is coming up, good luck. If you have a chance, please check out my website. And if you found this helpful, please subscribe. Thanks for watching.